Hello everyone. So let's talk about today's Geeks for Geeks problem of the day. So let's see what is given in a problem statement. So what is given in a problem statement? You have given a sorted integer array with a distinct element, and you here the sum of the array are moved to the either the adjacent position. Array of I may be present at array of I minus one or array of I plus one. Okay, and given an integer target, you have to return the index of that target, and if this target is not present, return the minus one. Simple binary search program or the searching program statement is also given the searching statement. You have to just with the one condition. Okay, so array of I may be present at array of minus one or array of I plus one. Let's see what is given in this condition. The problem statement is very easy if you know the binary search, if you know the linear search. Very means the problem is not level. I'm marking it as a basic level problem. Okay, so let's see how we will solve this problem. So you have given an array 1 2 3 4 5. Let's see what is given in a problem statement 1 3 and 5. Okay, so this is an sorted array. What they are saying, they just say the array of I means this element might be present on this index or it might be present on this index. What is meaning by this? So 2 3, so instead of 3 here it will present is here. Okay, and instead of here it will present on here. Okay, but it won't present at 3 will not present at here and here. Why? Because it will only present at I minus 1 index or I plus 1 index. Okay, so this is given in a problem statement. Now how you will search how you will find the target element using the linear search, which is very easy problem, but how you will apply the binary search on this problem? Let's see. Observe this. What I am saying, if it is a simple binary search problem and you have to find a middle element, what you do? You just find a mid and just check if mid is equal to target. Okay, this is the basic condition which you take. Okay, now what I am saying, as I mentioned in the problem statement, the ith index means a middle element might be present at mid minus 1 or might be present at mid plus 1. Okay, so I will add two more condition. Array of mid plus 1 is equal to target, then return mid plus 1. Okay, here return mid plus 1. Okay, if this is not satisfied, just check with the previous element, mid minus 1 is equal to target, just return the mid minus 1. Okay, are you agree with this? Why I am doing this? Because that my middle element might be present on I plus 1 index or it might be present on I minus 1 index. Although this is an sorted array, so you can apply the binary search as they mentioned the positions, and after that what you just check if the middle element is less than the target, just go with the s is equal to mid plus 1. So s is equal to mid plus 1. But why I go mid plus 1? Because I am checking mid plus 1 here already, so I'll go mid plus 2. And else I'll go e is equal to mid minus 1, means add element 2 is equal to mid minus 1. Now there is no need to drive in this example because this is the binary search simple problem. So let's try to implement it and let's try to code it out. Okay, so what I am saying, integer s is equal to 0, then integer e is equal to mid. Okay, mid, no, there is no mid, so I'll just take a n minus 1. Okay, now what is the n? I will define the n. Integer n is equal to array dot size. Okay, okay, nice. So this is all about the problem statement. So I'll just write a binary search standard code and I'll just calculate the mid. Okay, so just add it up. Integer mid is equal to s is equal to s plus e minus s by 2. Okay, this is the formula of my finding a middle element. Okay, if array of mid is equal to target, okay, this condition is satisfied, return the mid. If mid plus 1 is less than 1 what n, and array of mid plus 1 is equal to target, return the mid plus 1 as well. If mid minus 1 is greater than equal to 0 and array of mid minus 1 is equal to target, return mid minus 1. If array of mid is less than target, just do s is equal to mid plus 2, else e is equal to mid minus 2. Okay, now you have to do these two things, and if here is no possible, then return the minus 1. Okay, so this is all about the problem statement. So let's try to compile it, and if it get compiled successfully, let's try to submit it as well. Okay, let's check what is the error in the problem. So here I just forget the target spelling, so I know that will give the math problem target. So there is an answer target. Okay, nice. So I know that is the error. Let's see where is the error. Okay, so it get compiled successfully. Let's try to submit it. If it get accepted, let's discuss the time complexity. If it won't get accepted, let's try to fix it out. Okay, so it get accepted and a first attempt. So what is the time complexity? This is a simple binary search. The time complexity b of log n. Okay, so this is all about the problem statement, that we are not taking any extra space, and this is very easy and very simple problem. So just observe the what is given in a problem statement and let's try to implement it. So let's meet tomorrow with a new problem statement. Bye for today.